Hey guys, how's it going? Today we're going to be talking about the last section of chapter 7, which was the unit on independent living. So we're almost done. It's pretty cool. I'm feeling a little under the weather, so I'm kind of going to keep things short and simple today. Plus, the feedback that I've gotten from you guys is you really appreciate that. So the warm-up is going to be, today's section is 7.7, I'm sorry, home maintenance and improvement. We're going to be doing it in a different way than you might think. And then a warm-up, excuse me, for you guys will be to do this problem on a piece of paper and upload it into your HyperDoc for the warm-up section. So class of 20 students averages an 81% on the test. One student was absent and takes it later, which happens all the time. If he scores a 98, what is the new class average? So you guys just need to figure out the new class average. When we add in this one student that was gone, he got the 98%. What's the average? So I'll have you guys calculate that. Let's move on and just go straight to examples. So say you want to build a deck in your backyard, a rectangular deck, and we have to make sure it has 4 right angles. So we measure the sides and the diagonals. The sides are 10 feet and 24 feet respectively, and the diagonals are 26 feet. And we want to know, is it a perfect rectangle? So since we have 2 different side lengths, that's part of it being a perfect rectangle. So we really just have to verify that that diagonal works out for us. So the first thing we want to do is draw a picture and label it with the measurements. So check it out. Boom, there it is. Give me a super awesome laser pointer, right? Here's a rectangle, here's a side, here's another side, here's a diagonal. And based on the information that was given to us, one side is 10 feet. This one's clearly the shorter side, so let's label it 10 feet. This is the long side, let's label it 24. And it said the diagonal was 26. So we've got our picture, we've got our labels, we kind of know what we're working with now. Now we just need to verify if this is a perfect rectangle or not. So we're going to use Pythagorean theorem. If a squared plus b squared equals c squared, then I have a right triangle. And if I have 2 right triangles, that tells me something. So a squared plus b squared equals c squared. C squared is always the hypotenuse across from the right triangle. So I want to know if this is a right triangle, this would be my hypotenuse. So plugging in values for a squared plus b squared equals c squared would be, I don't know, let's just call this side A, this side B, and this side C. So plugging them in, 10 squared plus 24 squared should equal 26 squared. And then we use our calculations, and we find out that 10 squared is 100, 24 times 24 is 576, and 26 squared is 676. Now, simplify the left side. 100 plus 576 is 676, so I can verify, yes, this is a right triangle. So I know I have this. This is 90 degrees, right? So how do I know that this is a perfect rectangle then? If I think about that, I have a right triangle. How can I use the fact that I have a right triangle with side lengths 10 and 24, and then another triangle with 10 and 24 to verify that I have a rectangle? Well, the triangles have to be congruent because they share the same side, and also side angle side, right? If this is a 10 by 24 by 26 triangle, and this is a 10 by 24 by 26 triangle, this proof will hold and say that this angle is also 90 degrees. So by side angle side and side, as long as the diagonal is congruent, which it is, it's 26 and 26 in each one, then it's a rectangle. Boom. So trig is kind of going to come back and haunt us in this little section here. Nothing too crazy, just a little bit of SOHCAHTOA, a little bit of Pythags. But this is honestly the most you'll see geometry come up in real life is when you're kind of trying to verify these things as you're doing, additions to a home or something like that. You usually use just a little bit of trig, a little bit of geometry to get you through. And then trial and error will help. But honestly, most of the time you want to minimize the trial and error so that you're not spending an arm and a leg because you're wasting resources from like Home Depot or something. So let's go to our next example. You need your roof replaced. Ugh, that is such a pain, especially with all the rain we've been getting. You need your roof replaced, and it's expensive too, trust. And the steepness of the roof affects the price of labor because the steeper the roof, the more dangerous it is for the people that are coming to replace your roof. Mathematically describe the steepness in the roof drawing below. So here's my very basic shape of a house. Here's my roof, right? I know this is 60 feet, this is 34 and 34. So I need to know how steep my roof is. How big is this? This like angly, I guess, angle right here. How can I measure that? So roofers describe the steepness as a pitch. We call it the slope. So we're really just trying to figure out the slope of this guy. So let's just use what we know about slope, right? Slope is rise over run, where this would be like rise, and this would be run, right? How much is it rising, and how far across is this piece going? So the rise is going to be this height of this isosceles triangle, right? They have two of the same length size and one different. The rise is this height, and the congruent triangles form one when we draw this picture. So let's use our Pythagorean theorem to find the height. Now, if this entire thing is 60 feet, we're also going to make an assumption that this is cutting it exactly in half, that the house is completely symmetric. So that's an assumption that we're going to be making here. But Pythagorean theorem is a squared plus b squared equals c squared. A squared is probably this height right here. I guess we're going to go and say this is a squared plus b squared. This is going to be half of 60 or 30. And c squared is this hypotenuse right here, assuming that this is a right angle. That would have to be my hypotenuse. Squaring 30 gives me 900. Squaring 34 gives me 1156. If I subtract 900 on both sides and take the square root, we get that a is 16. So the steepness is 16. Notice this is in feet, feet, feet. This height right here is 16 feet, which is pretty dang high. So we found the rise, right? Now we need the run. How long does this extend for? Well, we already talked about that. The run is going to be half of the width since the roof is an isosceles triangle and the height is bisecting this space right here, or this top of the roof area. So the run is going to be half of 60, just like in Pythagorean theorem, we used half of 60 for b squared. So we're just going to plug in 30, and you can leave it like this, or actually, I noticed that 16 and 30 are both even, so I could reduce this fraction to 8 over 15. You can convert that to a decimal if you'd like, but 8 over 15 is just fine. Next example, you need to reach the rain gutters on your house with a 12-foot ladder. Maybe they're backed up, they're broken, they're about to fall off. I don't know. You use a clinometer to measure the angle of elevation at 68 degrees. How high are the rain gutters? So you don't know exactly how high they are on your house. You know that from the floor, the angle of elevation is 68 degrees. A clinometer is like a super cool tool that you can use to like find out angles very precisely. And the ladder you're using is 12 feet. This essentially boils down to an angle of elevation or an angle of depression type problem from geometry or trig. So this one is obviously a angle of elevation since it says that wording in there. How high are the rain gutters? It always, always, always helps to draw a picture when you're doing trig stuff. So here's my house, right? I've got my ladder. It's going to be 12 feet. And my rain gutters are going to be somewhere around, I don't really know. But I can't use Pythagorean theorem because I'm only going to know one side, and I don't know if it's going to be a special right triangle at all. So I've got to use trig. So if I draw my picture here, right here is going to be my ladder. So this is what I know. I always recommend starting off with like drawing a picture and making an image of what you know. So I know that this is my ladder and this is 12 feet. I know that my angle of elevation from the floor excuse me, from the floor up is 68 feet, and I want to know how high up is this? What is this height? So I'm going to have to use SOHCAHTOA, right? Sine is equal opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if this is my angle, theta or whatever, this is the opposite side. This is the adjacent side because it's right next to, and this one, I'm sorry, this one's adjacent, and this one is across from this. I'm assuming this is a 90-degree angle. This one is going to be my hypotenuse. So I like to think about what I know and what am I trying to find, right? I know this side length right here. Wait, let me move it to a pen, right? I know, and I like to label it. So I know, or not, I know that this side, cool, let's just not. Aw, thought it was gonna work. Whatever. This side, follow along, I would label this as equal to hypotenuse, that's the H, so I know I have an H in there. This side is opposite, so that's O. So I have O and H. Which of these, SOHCAHTOA, has O and H in it? It's going to be sine. Sine of our angle is going to be opposite over hypotenuse, and that's what I want. So when I tell you guys, like, mark off what you have and what you want, that's what I mean. I really don't know. Ah, there it is. Sorry, this is a little janky right here, but let me just mark this in there because I think it's helpful. So this is our hypotenuse. This is O. Now I know that looks sketchy. And we have this and this, O and H. So that must mean that I'm going to use this trig function. Sine of this angle, this is my angle, is opposite over hypotenuse. So we plug this in. Sine of theta is opposite over hypotenuse. Sine of 68 degrees is going to equal my opposite leg, or H, over my hypotenuse, which is 12. Then you use your calculators and figure out what sine of 68 degrees gives you. And that is 0.927. Now we're stuck here. This is just a one-step equation. Multiply both sides by 12. Let's get our times right. Times 12 times 12. Forgive me, I'm doing this with the mouse, so it's kind of messy. Times 12 times 12. And we end up getting that 11.13 is the feet. So it's 11.13 feet high is where we are saying that if this was X marks the spot, that's where our rain gutters are. And we're actually going to use this in the next problem. So that was a little SOHCAHTOA deal with angle of elevation. Now, same situation, we still got our house. If we buy a 14-foot ladder instead, what is the angle going to be? So instead of having the angle known, I'm going to have this side known because we just found it, 1113, and this side we're going to change that and figure out what must this angle be to make this a true statement, also using SOHCAHTOA. So here's our diagram, right? We don't know the angle anymore. This is my ladder. This is 14 feet, and this guy was the height that we just found last time. How can we use SOHCAHTOA to figure this out, right? If this is theta, and draw the Greek letter theta, which means angle. That's a weird equal sign. If this is theta, no, not laser. This is theta, my angle. And respect to theta, this value, this is my right angle. So this guy is still my hypotenuse. This guy is still my opposite side. Oof, that's a bad O. Just roll with it, people. Which trig function am I going to use that has O and H? It's still going to be sine, but now we have to do something special with it. So sine of theta is opposite over hypotenuse still. So I'm going to plug in opposite is 11.13, hypotenuse is 14. The problem is we don't have theta. We don't have this value of x. So what we're going to have to use is an inverse trig function. So the only way to undo sine is to use inverse sine. And it's like sine to the -1 power. That's what that looks like. So First, let's simplify 11.13 over 14 using a calculator, get 0.795. And then this is what I mean. We have to use inverse sign next to sign because when things are inverses, they undo each other. So these two cancel each other out. And whatever I do to the left-hand side, I absolutely have to do to the right-hand side. See, they're canceling right there. And we end up with x equals 52.7 degrees. So in the last example, we had a different theta. Now, if these are the constraints, I have a smaller angle because this is higher, right? 52.7, the last one was like 60 something. So that's the end of what we're doing for your guys's assignment today. I have a trick joke thing for you guys to fill out, and yeah, just doing a little bit of SOHCAHTOA to get us reminded of trig and how you're going to be using this for our homework and how you could potentially use this in your yard. Alrighty, thank you so much, guys. Thanks for hanging in there with me. I apologize for coughing every now and again, and I hope you have a great Monday. Bye!